Good afternoon, class. Here's Chapter 8, Further Application of Trigonometric Functions, Section 8.6, Vectors. So we covered this law of sines, cosines, polar coordinates equations, and graphs, complex numbers, the Morse theorem, and now vectors. The objectives are graph vectors, find a position vector, add and subtract vectors algebraically, find the scalar multiple, and the magnitude of a vector, find a unit vector, find a vector from its directional magnitude, model with vectors. Reminding of the polar coordinates, we have the x and y axis. In the case of a polar coordinate, we have the x-axis and the angle. So this distance is r, x, y. The relationship is as follows. X squared plus y squared equals r squared. Tan theta is y over x. We adjust for the quadrant. X is r cosine theta, y is r sine theta. And polar formats can be represented in infinitely different form because we can add a 2k pi. If you want r to be negative, then we add odd multiples of pi. And these are some examples in a rectangular coordinate versus a polar grid. Note, a pole has coordinates r comma theta, where r is 0 with any theta will do. For complex plane, remember a plus bi, now z is x plus yi, the same thing, where I squared of -1, I squared is -1, I cubed is negative I to the power of 4 is 1. The magnitude, also known as the modulus, is r squared of x squared plus y squared. And we can go with x squared plus y squared or z bar, where z and z bar are complex conjugates. If you multiply and get x squared plus y squared, reminding you that a plus bi and a minus bi, the product is a squared minus b squared I squared, which makes it a squared plus b squared because I squared is -1. X is r cosine theta, y is r sine theta, as it was mentioned. So z is x plus yi or r cis theta. That's a shorthand notation. And this is a complex plane. And with complex plane, the x-axis, the real axis, the y-axis, the imaginary axis. Z is r cis theta, or r e to the power of I theta. R squared is x squared plus y squared, and tan theta is y over x. Z1, Z2, the product, we can multiply R1 and R2, their modulus, their magnitudes, and then add up the arguments of cis. So cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. And here's the shorthand notation. For division, we divide their magnitudes and the difference of arguments. Cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. The Morse theorem says if you want to raise z to the power of n, raise r to the power of n and multiply the argument by n. So r to the power of n cis n theta. If you want to take a root, you write this and you take a root as follows: the nth root of r, and then cis cosine of theta over 0. So you're going to put the r and you use k equals 0, 1, 2, and so forth. 2k power n or 360 degrees k over n, it means the same. And now 8.8 vectors, geometric vectors and scalars. Vector is a quantity that has both magnitude and direction. Scalar is a quantity that has magnitude only. Examples: weight versus mass, velocity versus speed. For example, you're doing 50 miles per hour north or 50 miles per hour south. When you go 50 miles per hour north is the same as going negative 50 miles per hour south. That's the velocity. In both cases, the magnitude or the speed is 50 miles per hour. And so this represents a line PQ because it goes indefinitely on both sides, but this one is a line segment ends at P and Q, and this is the initial point of a vector, terminal point of a vector. It's a directed line known as a vector. A given vector PQ, magnitude is distance from P to Q, and direction is direction from P to Q. So vectors are equal. V equals PQ, V equals W if they have the same magnitude and direction. So if you look at PQ, RS, TU, they're the same because they are parallel and they have the same magnitude. Of course, same direction. Vector properties of addition and scalar products. Vector addition is commutative and associative. Vectors V and W, scalars alpha and beta. So these are two numbers. If we want to add them up, we can add them up in any order. V plus W or W plus V makes no difference. Now, if you have two of them becomes commutative. If you have three of them, U plus V plus W is U plus V plus W. It's associative property. When you add it with zero, nothing happens. The same vector. This is not a regular zero. It's a zero vector. Sometimes they show it like this. Zero vector like this. Okay. And this is the negative of V. They add up to zero again. Both of them are vectors. So definition V minus W is just as we did in the beginning of learning subtraction is V plus the negative W, okay, the opposite of W. And so properties of scalar products, multiplying vectors by number geometrically or scalar product. If you multiply by zero, the vector becomes zero. One is the same vector. Negative one, it gives you the opposite, okay, which is parallel, the same magnitude in the opposite direction. Alpha plus beta times V, we can multiply alpha and then beta. Alpha times V plus W, we can distribute it alpha V plus alpha W, alpha times beta V in any order. Bear in mind, alpha and beta are both numbers, everybody. Are both numbers. I can't emphasize this enough. So it's pretty straightforward. So if we look at the erase mine, if you look at this vector V, we multiply it by two, same direction, parallel to that, but the magnitude is two times that. Minus V or minus 1V, parallel to that, but the opposite, or same magnitude. The direction is the opposite direction. Adding vectors. We can use a geometric approach as a triangle, okay? So here's V, here's W. We put this is the initial point of V. This is the terminal point of V. This is the initial point of W. So terminal point of V to initial point of W, and then initial point of V to the terminal point of W gives you V plus W. This is the method of triangle. This one, also the same thing. You can say W plus V. Remember, this one is parallel to W. It's identical to that with the same magnitude. This one is parallel to V, and therefore they are identical because it has the same magnitude, the same direction. W plus V or V plus W makes no difference. So that's commutative property. Order is not important. Associative property. Take a look at what happens. We can say U add V becomes U plus V. And now add W, and this red one is the sum of all three. So U plus V plus W, or you can say U plus V plus W. So look at V and W, ignore the U. V plus W is what? V plus W. So if you want to add U to it, you get the same thing. So associated. U, V, W. U, V plus W. So I hope it's clear. You do it in any order, you get the same answer. Opposite vector. V and its opposite, they add up to zero vector. This is not a regular zero, zero vector. So V and negative V, they have the same, they're parallel, they have the same magnitude, but opposite direction. They cancel each other, they give us zero. So vector, zero vector, V plus zero, zero plus V gives you the same vector back. The difference, V minus W, is V plus the opposite of that. So here's V, here's W. Okay. Here's V minus W. Here's V plus W. Okay. Because if this is W, V is that, the same as this one, right? They're parallel, identical. W, this one is negative because look at the direction of W versus the negative W. So you connect these two and you get this one as V minus W. So here's the V vector, just as this one. Here's the minus W vector, just as this one. And the initial point to the terminal point results in V minus W. So one way to think of it, if you have V and W, if you connect the terminal point of W to terminal point of V, gives you V minus W, terminal to terminal. Instead of initial to the terminal, that gives you V plus W. Initial to terminal gives you the sum, terminal to terminal gives you the difference. Of course, the terminal of the second one, meaning W in this case, the one that is being subtracted. All right, graphing vectors, we are given V, W, U, and we are coming up with the following part A, V minus W. That's the first one we want to come up with. And so V is fine, W, we get the same thing, but in the opposite direction. So we can put it here. So this is parallel to that, has the same magnitude, but the direction is the opposite. So according to this is minus W. This is the answer, and it looks like this, V minus W. Just in case, so you know, if you said this is W, and you connect terminal to terminal. This is also the same as V minus W. Okay, as it was mentioned before. 2V plus 3W. So here's the V, make it 2 times larger. So the same direction, just the magnitude is more. W, make it 3 times. So this is 2V. And this one is 3 times W. And now you put them together. This is 2V plus 3W. Now 2V, we have it here. W and then so this is minus W, the same thing, put it here, right? This is the same as this one, minus W. And then plus U, put it here, minus W, plus U, and then connect. And you get 2V minus W plus U. A quick recap. V extended by a factor of 2 becomes 2V. Minus W, we already had it, just put it up here, right? It's parallel to that. Or just the opposite. And then U, put it to the terminal point of minus W, and then connect this. The initial of 2V to the terminal point of U. That's what you get. Magnitude of vectors. So we use like absolute value, but double. So to compute the magnitude and direction of a vector, an algebraic way of representing vectors is needed. Position vector. If V is A comma B is an algebraic vector whose initial point is at the origin, then V is called the position vector. So by definition, any vector can be a position vector as long as its initial point has been moved such that it's at the origin. So we can write them in the following manner. We can write them like that, or we can write them AI plus BJ. I is the unit vector along the x-axis, J is the unit vector along the y-axis. For this format, A and B are called components of the vector V. So magnitude of a vector, or the modulus, is squared of A squared plus B squared. Just like before, it makes perfect sense. The magnitude is either positive or zero. The magnitude of two vectors that are opposite must be identical. So the magnitude of V and minus V are the same. If the magnitude is zero, the vector must be zero. So this can only be zero if both components are zero. And that means you're talking about the zero vector. A times V, A is a number. You can take the A out, but put it in an absolute value because in case A is negative. And unit vector is defined as a vector U with the magnitude equal to 1. So a vector that has a magnitude of 1, that means square root of A squared plus B squared equals 1, because, and then of course, if you square it is 1, even A squared plus B squared ends up being 1. It's known as a unit vector. A vector with initial and terminal points, P, the initial point x sub 1 and y sub 1, Q, the terminal point of x sub 2, y sub 2, is equal to the position vector. V is the position vector, PQ, x sub 2 minus x sub 1, y sub 2 minus y sub 1. Okay. And so, or a comma b. Now, note angle brackets. These are called brackets, but angle brackets, sometimes known as chevrons, are used to represent vectors. Okay. So take a look. If you're looking at this one, this has the initial point at the origin. So a comma b represents this point and therefore represents the vector. If you look at this one with coordinates as it was mentioned, x sub 1, y sub 1, x sub 2, y sub 2, this distance is x sub 2 minus x sub 1, this is y sub 2 minus y sub 1. You just move this such that this is here. So this a must be equal to x sub 2 minus x sub 1, and this b must be y sub 2 minus y sub 1. Find the position vector of the vector v equals p1, p2, where p1 has coordinates negative 1 and 2, p2 has coordinates 4 and 6. So according to this, x sub 2 minus x sub 1, y sub 2 minus y sub 1. Okay. P1 is located at negative 1, 2. P2 is located at 4, 6. X sub 2 minus x sub 1. That means 4 minus minus 1. And y sub 2 minus y sub 1. That means 6 minus 2. And this becomes 5. This becomes 4. And now this one, 0, 0, and 5, 4. That would be the same as this one, but it's a position vector because the initial point is at the origin 0, 0. Theorem, vector equality. Two vectors are equal if their corresponding components are equal. And remember, this is the position. V has components A1, B1 is equal to W that has components A2, B2, as long as A1 is equal to A2, B1 is equal to B2. So if their components are identical, the two vectors are the same. Unit vector is a vector used such that its magnitude is 1. Unit vectors I and j, vector a comma b, is a times 1, 0 plus b times 0, 1. This is the unit vector I. This is the unit vector j, so ai plus bj. So the components 1, 0 for this one, the component 0, 1 for this one. So if you look at this one, I, so you choose 1 along the x-axis, 1 comma 0, and this is the I vector. And you choose 0, 1 along the y-axis, and this is the j vector. Unit vector along the x-axis is called I, and along the y-axis is called j. Of course, both of them have the initial point at the origin or 0, 0. This one has the terminal point at 1, 0 becomes I. This one has it at 0, 1 becomes j. Find the position vector of this vector v with p being at 4 comma 9, q being at 4 comma 6. Well, x sub 2 minus x sub 1, y sub 2 minus y sub 1. So 4 minus 4, 6 minus 9. That would be the position vector for v. And this gives us 0. This gives us negative 3. And because the A component is 0 and we only have the B component, in essence, AI is 0, BJ is negative 3J. Find a vector from its direction and magnitude, the vector P1, P2 with components AB. Unit vector is defined as a vector such that the modulus of magnitude is 1. So unit vector in the direction of V, if you want to find the unit vector in that direction, all you have to do, find the magnitude of that vector, divide the vector by that. That means divide the components. So find the vector from its direction and magnitude. So in that case, V would be the product of these two. The magnitude times the unit vector. Unit vector is cosine alpha I plus sine alpha j. This is the unit vector. Y cosine squared plus sine squared is 1. So this is a unit vector, everybody. How do we know that? Sine squared plus cosine squared is 1. So this is the I vector, this is the j vector. Okay. So this point has cosine alpha sine. If you pick any point with any angle on this unit circle, this is the unit circle, right? X squared plus y squared equals 1. If you pick any point with any angle, including this one, angle alpha, the magnitude is 1. It makes it a unit circle. Therefore, the magnitude is square root of a squared plus b squared. U in the same direction would be divide the vector by its magnitude, and v is the product of the two. So example 3, find the vector v whose magnitude is 7. This is 7. And whose components in the I direction is both positive and equal to the component in the J direction, which of course means the first quadrant, everybody. So along the I direction, right, along the x-axis is positive and is equal to the J. So a squared plus b squared is 7 squared. And what is given is the magnitude. So the square root is 7. V is AI plus BJ and A equals B. So one more time, what is given? The magnitude square root of A squared plus B squared is 7. That's what it says here. And A and B are the same. So we know that V is in general is AI plus BJ. It happened that this indicates that A is equal to B. So pretty straightforward, everybody. So that makes it easy. So basically, uh, replace the b with a or a with b. A squared plus b squared 7 squared is easier to deal with it that way. So this one, I can replace it with a squared, and I get 2a squared, and 7 squared is 49. A squared is 49 over 2, and a is square root of that. So a equals b equals square root of 49 over square root of 2, or 7 over square root of 2. I can multiply by square root of 2 over square root of 2 to rationalize, and we get those. So v equals 7 square root of 2 over 2 times I plus 7 square root of 2 over 2 times j. So we got the vector v. Finding a unit vector, as we said, the magnitude is 1, and this is the information from before. There is nothing brand new here. So example 4, find a unit vector in the same direction for the vector v, which is equal to negative 3i plus 4j. So that means you want to find this class. To do that, the very first thing we're going to find the modulus or magnitude, which is square root of a squared plus b squared. And this is 9, this is 16, they add up to 25, it comes out as. So basically divide this one by 5, that's all. So the unit vector would be the original vector divided by its magnitude. So we get negative 3 over 5i plus 4 over 5j. That's the vector. Now, it's not a bad idea to check. Now, how do you check? Just if you raise this to the power of 2, raise this to the power of 2, they must add up to 1. So if I raise this to the power of 2, I get 9 over 25. Over here, I get 16 over 25, which is 25 over 25. And it's 1. Of course, square root of 1 is 1. Even if you don't do this part, this is good enough. Okay, we want actually the square root of 1 to be 1. We either way is either way is fine. Find the vector from its direction, and the vector is the magnitude times the unit vector, cosine alpha I plus sine alpha j. So alpha is the angle between the v vector and the positive side of x, the I. in essence. Find the direction angle of V equals negative 3i plus 3j. So first and foremost, let's graph this. So over here, we go 3 units to the left because it's minus 3, and 3 units up. So 3 units left, 3 units up. Tan theta is b over a, so 3 over negative 3, and you have to adjust for the quadrant. Negative 1, and pay attention that it's quadrant 2. Negative 1, if you go with the tan inverse, everybody. Okay, let me just make sure we understand this. If I write theta is tan inverse of negative 1, then theta becomes minus 45 degrees, because that's how remember the restriction we put from minus power 2 to power 2 for it to have an inverse the tangent function. But because we know this belongs to quadrant 2, we just have to add pi or 180 degrees, and that makes it 135 degrees. So theta is 135 degrees. That's all we're looking for, theta or alpha. Okay. Example 6, and they may call it alpha, they may call it theta, whatever the angle that they call it. Find the vector v whose magnitude is 9. That means square root of a squared plus b squared is 9. And the angle it makes with the positive x-axis alpha is 225 degrees. So this one is 225 degrees. That means 180 and then add another 45 degrees. Okay, which puts us into the third quadrant, 225 degrees. Quadrant 3. So we're going to put it here, and alpha is replaced with 225 degrees. So the magnitude is given as 9. V, which is AI plus BJ or AB, okay, it's A, according to this one, is 9 cosine. And B is 9 sine of 225 degrees. And remember, 45 degrees, sine and cosine are the same, square root of 2 over 2. But in the third quadrant are negative, both of them are negative square root of 2 over 2. So we get V equals minus 9 square root of 2 over 2i minus 9 square root of 2j. All right, we're going to add and subtract vectors algebraically. Vector properties of addition and scalar products have been discussed. Okay, so if V is A1I plus B1J and W is A2I plus B2J, we have the components, and alpha is a number, is a scalar. V plus W, basically add up the components, A1 plus A2 times I plus B1 plus B2 times A, or A1 plus A2 and B1 plus B2. And if you subtract it in the same manner, A1 minus A2 times I plus B1 minus B2 times J, so you work with the components. If you are looking at this one, this is V, having components A1 and B1, W having components A2 and B2, their sum has components A1 plus A2 and B1 plus B2, where this is A1, this is A2, they're being added. That's the concept. Alpha is the number, is the scalar, times V, we are going to multiply it by the components here or here. Alpha A1I plus alpha B1J, alpha A1, alpha B1. Meaning, if this is a V and we're going to multiply it by a number, we're going to extend it in the same direction by a factor of alpha. And again, magnitude, reminding you that's the formula, square root of A1 squared plus B1 squared. Okay. So the magnitude, this is A1, this is B1. The magnitude is distance that O makes to the point P1. Add and subtract vectors algebraically. V and W are given. So what is V plus W? Just add them up. These two add up to negative I. These two add up to negative J, and we're done. That's all there is to it. What about V minus W? We just write the components and distribute the negative. We get negative 2I here plus 5J here. Negative 3I minus 2I, they add up to minus 5I, 4J, 5J, they add up to 9J. Very straightforward, everybody. We're going to continue working on more examples. We want to find the scalar multiple and the magnitude of the vector. The V and W are given. So 3 times V. We're going to multiply the components by 3. So 3 times negative 3 is negative 9. 3 times 4 is 12. 2V minus 3W. So 2 times V, which is negative 3 comma 4, and minus 3 times 2 comma negative 5. So just distribute. This becomes negative 6. Imagine it's parentheses and distribute. This is 8. If you want to keep the minus, you can, or just change it to a plus. So anyways, 3 times 2 is 6. 3 times negative 5 is negative 15. And now this means plus minus 6 positive 15. And if we add negative 6 and negative 6, we get negative 12. And we add 8 and 15, we get positive 23. So that's pretty straightforward, everybody. What is the magnitude of V? Square root of A squared plus B squared. So negative 3 quantity squared plus 4 squared and 9, 16, 25 comes out as 5. We know that already. Model with vectors, resultant force, we have force F1, force F2, they add up to a resultant force F1 plus F2. A plane is flying at a speed of 200 miles per hour on a bearing north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree. So let's see what is given, everybody. So we have V sub A going in the direction of north 55 degrees east, which makes this angle 55 degrees. Which makes this angle 90 minus 55, 35 degrees. The plane is flying. This is the velocity with respect to air, everybody, VA. The magnitude, the speed is the magnitude, 200 miles per hour. The alpha is 90 minus 55 or 35 degrees. So that's as far as V sub A is concerned. Here's the wind. The magnitude is 35 miles per hour, and it's parallel to the x-axis because it's from west to east. It's going this direction, so the angle is 0 degrees. So this makes a 0-degree angle with the positive side of the x-axis. So that's explaining what's given. What are we looking for? We are looking for this, the magnitude of this. This is the velocity with respect to the ground because they two add up. And then if this angle is theta, then the true course would be north, east, and this angle. So that means north 90 minus theta east. So we find this angle. This is the magnitude, north 90 minus theta east. Okay, that's how we find the true course of it. So that is explaining what we are planning to do. That's what we are planning to do. So components, they add up. So that means we need to add those two. And to add those two, we go with the components using this. The vector is its magnitude times its unit vector, cosine alpha I plus sine alpha j. So 200 is the magnitude, cosine of 35 degrees I plus sine of 35 degrees j. Now, 35 degrees is not a common arc. You have to use a calculator to find cosine of 35 times 200, find sine of 35 times 200. When we do that, we end up with 163.83 I plus 114.72 J. This one is simple, 35 cosine of 0 degrees is 1, sine is 0, so simply 35i. So if we want to add them up, we just have these two components to add up. This one, just we keep it. So velocity relative to the ground, V sub g, is the sum of the two. So we add these two numbers, 163.83 and 35, 198.83, I plus this one doesn't change, 114.72 J. Now, what is the magnitude? We are looking for the ground speed. Well, Square root of a squared plus b squared. So square this number, add them up. 198.83 quantity squared plus 114.72 quantity squared. And it ends up being about 230 miles. So as the number of decimals, you always follow what they tell you to do. So we have the magnitude. Approximate the ground speed, we approximate. Now the true course. We can find theta as b over a. So this number over this number, 114.72 divided by 198.83. So theta is the tan inverse of this number. It's in the first quadrant, and it ends up being 29.98 from the calculator, almost 30 degrees. So if 30 degrees is theta, this must be 60 degrees. So we are doing 230 miles per hour. That's our speed, the ground speed. And we are going north 60 degrees, 90 minus 30, east. 230 miles per hour, north 60 degrees east. Example 10, a box that weighs 1,200 pounds is suspended by two cables as shown. Find the tension or magnitude in each cable. An object in static equilibrium, so it doesn't move. Free body diagram looks like that, so you draw a rectangular coordinate system. In essence, here's the x-axis, there's the y-axis, F2. Let's call this F2. If this is 45 degrees, so is this one. Let's call this F sub 1. This is 30 degrees, so it makes this one 150 degrees. And F3, 1,200 pounds down. So what is a free body diagram? Free body diagrams show two or more forces acting on an object or body. If the object is in an equilibrium state, all forces must add up to 0. Static equilibrium. So vector has magnitude. So in this case, F1 is a vector. Magnitude of F1, cosine of 150i plus sine of 150 degrees J. So that would be F1, right? What about F2? Magnitude of F2, cosine of 45i plus sine of 45j. What about F3? We know it's 1,200 pounds, so the magnitude is 1,200 pounds. And it's going down, so minus 1,200 J. If you don't recognize it, just do this, everybody. Say this angle is what? 270 degrees or 3 power 2. What is cosine of 3 power 2? 0. What is sine? -1. That's how we end up with negative 1,200 J. And now a free body diagram. So the sum of everything must be 0. So there are three sums. Summation of F, if you add them up, you get 0. Summation of F in the I direction, they must cancel each other. That means this one has a component on this side, everybody. I want to make sure we understand this part. The component on this side comes from f sub 2 on the right side. From the left side comes from f sub 1. They have to cancel each other. Now, component from f2 along the y-axis is up here. For f1 about the y-axis up here. Sum of the two must cancel f3. That's what happens, okay? And so with that being the case, f1 plus f2 plus f3 is 0. And let's calculate. Remember, 150 degrees is the same as 30 degrees. 30 degrees is the reference arc. And in the second quadrant, so cosine of 30 degrees, second quadrant, cosine is negative, minus square root of 3 over 2, and sine is positive, okay? 45 degrees, both of them are square root of 2 over 2. So we add them up. This one is minus square root of 3 over 2 times f1i, okay, plus 1/2 f1j. That's the first one. Okay. As the second one. Magnitude of f2 times cosine, which is square root of 2 over 2 I, and then magnitude of f2 times square root of 2 over 2 j, and finally f3 is minus 1200 j. So it's pretty straightforward. I hope everybody is following what we are saying here. Let me erase my work. So we're going to combine the I components, and we're going to combine the J components. So we combine these two, everybody. We combine these two. We get minus square root of 2 over 2 f1. F1 is a number, remember that. Plus square root of 2 over 2 f2. The magnitude of f2 is 0 because along the I component. And now along the J component, we have this one, and this one. Add them up to 0. Now, please understand, this is a system of equations that involves f1 and f2, and you want to solve that. And I'm going to show you the next page how I solve it. But solution to this is not that big of a deal. I give you the solution from the next page, and on the next page, we will go through the process of solving that. Ends up precisely 2400 over square root of 3 plus 1. You put it into a calculator, roughly 878.5 pounds. That's F1, the magnitude. F2, the magnitude is square root of 3 over 2 times this. And that ends up being 1075.9 pounds. Now I want to show you how to solve this. So I'm going to take this set to the other side. And I'm going to solve. So the very first thing we do, we get rid of the denominator. Let's multiply this one by 2, this one by 2, and let's move this one to the other side. So when I multiply by 2, here's what happens, everybody. This one loses the 2. This one loses the 2. This is fine. This one loses the 2. This one loses the 2. Minus 1200 becomes 2400. Goes to the other side, becomes positive 2400. You recognize they're identical. You can say subtract one from the other, or you can multiply this one, let's say, by -1. So this becomes positive, this becomes negative. And now you can add them up. When you add them up, these two cancel each other. So you have these two, which is square root of 3 plus 1 times the F1, magnitude of F1. And so magnitude of F1 is 2400 times square root of 3 plus 1. I hope you remember we had it in the previous page. And now you put that into either equation 1 or 2, makes no difference. If we put this into equation 1, and we're going to use the exact answer, we get minus square root of 3 over 2. Always go with the original equations, okay? F2 is square root of 3 over square root of 2 F1. So multiply this by square root of 3 over square root of 2, or square root of 3 halves. Again, this is an exact answer. You put it into a calculator, you get 1075.9 pounds. That's an exact answer, everybody.